This episode is a tutorial on spawning projectiles, and we're laying the groundwork for gameplay abilities. Welcome to today's episode, and today it's all about projectile physics and collision. And this episode, we're really at the very start of doing gameplay abilities for the game that we're making. We're not doing any animation yet, that's coming up next episode, but we're setting up everything we need to animate, which is a projectile that the player is going to throw. This is the first unique aspect of the platformer that we're making. I want our player to be able to throw something that spawns geometry, that spawns something that they can jump on. A lot of new concepts today, mostly related to physics, but also creating a new actor, spawning that actor at runtime. So let's get to it. So we are going to start today by creating our BP Projectile Blueprint. Now, the BP Projectile, there is one already if you go into the first-person shooter template, but I'd rather have you understand it by building it from scratch, and it's not too complicated to build. So let's go over to our Blueprints folder, and then we'll right-click here. We'll create a new Blueprint class, and similar to previous episodes, we're going to make this an actor, and I'm going to call it BP_projectile. And we'll go into that. First thing we're going to do is we need a collision sphere around our projectile. So I'm going to add and I'm going to search for collision. I'll choose sphere collision and I'll title it sphere collision. Compile and save that. And then on the right hand side, if we scroll down to collisions, the collision presets, we got to make sure that this is block all dynamic. And then that way this projectile is going to collide with just about anything that's solid. So then we can add our actual mesh, and this is going to be our actual projectile, and we're going to add a sphere. And we see our sphere is a lot bigger than sphere collision, so we've got to resize that. If I select our sphere, go to our scale, I'm going to make that 0.45 in all axes, 0.45, just like that. And our sphere collision's a little bit too wide, so if I go back to sphere collision, we can change the radius here to 25. Perfect. Compile and save. For the mesh, if you go back to the sphere, I'm going to set this to no collision because we're going to get all of our collision from the actual sphere collision, which is better performing. And there's a couple other settings that we're going to set here. So we are going to simulate physics. We got to make sure that's checked, and make sure it's checked only on the sphere collision. You always want to make sure that the parent, that's what has physics. And if we have physics, then we can also make sure gravity is enabled. Compile and save this. And then what we can do, if we go back to our folder, actually I'm going to minimize it, drag it into our world here, put it up in the air and begin play and see if it drops. Okay, there's our ball bouncing on the ground, and then, wait, let's see, can we... Goal! Wait, no, it's not a goal. So we see that we got basic physics working on our ball, but, well, it doesn't actually work like a soccer ball, does it? A football, sorry. It doesn't work like a typical ball because, well, its mass is quite high. So let me show you what's actually controlling that. If we go back to our blueprint, and if we look at our sphere collision here, if we scroll down, you'll see a bunch of different settings under physics, and one of those is the mass in kilograms. Now, it was set to 23, but if I set this to something like 2 kilograms, compile and save, and now let's try playing soccer. Football. Goal. Yeah, then it's boom, right out into the distance. And I want to mention a few other settings here that are important. So these two, linear damping and angular damping, they're related to inertia, how quickly that object comes to a standstill. And if I hold Control-Alt on a particular setting, I can get more information. This adds a drag-like effect to the physics body, but more accurately, it defines how much the physics body resists moving. And the same goes for angular damping. They're both inertia settings, but this one is linear force, and then this one angular, like turning force. So right now, this ball is going to keep on turning. It's basically a perpetual motion machine in terms of rotation. And then constraints. These are also good to know about. So you can lock a particular axis. So for example, if you just wanted it to spin this way, you could lock the Z axis, the vertical axis. And the same goes for a position. Like if I didn't want it to be able to go up and down, I could lock the Z. So if I compile and save this, you'll see it's actually stuck in space. Just like that. So if I had like a pinball game and I didn't want to have the ball be able to like go up into space, that's what you could do here. Let's turn up our linear damping to like 0.9. So compile and save, and I'll just show you what that does. So yeah, so it falls very slowly, and then if we kick it, yeah, so it doesn't have much mass. It moves pretty fast initially, but then it slows down a lot faster. So now let's set up the ability to project this projectile from a standing position like we're throwing it. We're not going to do throwing this episode, but that's next episode. So if we go back to our blueprint, let's put our linear damping down to 0.01 and our angular damping at 0.5. I feel like a Star Trek engineer. Compile and save. The other thing I like doing here is checking ignore radial impulse and ignore radial force. And what that's going to do is it's going to actually reduce the amount of physics calculations that are needed on the object. It basically makes it better performing because it's not going to have to figure out how much to rotate the thing anytime a physics force is applied. Compile and save this. And now we have to create our input action for throwing our projectile. So let's go back over to content, into variant platforming, into our inputs, and then into our actions. And we'll right click and go to input and then input action. And it's going to be IA_throw. And we'll go into that. There's one thing that I want to do here, which is under triggers, I want to hit plus sign here. And for the index 0, I want to do a hold trigger. And the reason I'm doing this is I want the player to be able to just hold down a button and continually throw. It depends on the ability that you're using, right? So some abilities you might not want that buffer throwing in the gameplay I've got in mind. I think it's just going to be easier for the player. And I'm going to keep the hold time threshold down to 3 seconds. So it's basically a burst. Like you can throw, and then it's going to force you to re-click. And feel free to set this to whatever you like. It doesn't have to be 3 seconds, but that's just what I found to be effective. And once we begin to do some gameplay testing with this, feel free to go back and change it. But I found it to be a good setting for now. So we can save this. I can exit out of this. We go back to our input actions into input. If I go under IMC platforming, we're going to add a new mapping. And this one is going to be our IA throw. And if we expand that, I'm going to add 2 buttons. So keyboard E, and I'm also going to add one for a gamepad input. So I'm going to do plus sign, and this one, if I search for gamepad left trigger digital. So E is going to be for throwing, and then in a couple episodes, we're going to begin our attack, which is going to be our left mouse button. So we'll save that, close out of this, and now we've got to open our platforming character because we're just about ready to test this out. So if we go to our blueprints here, platforming character, we go underneath our camera zoom. Once again, we need IA_throw. There's our enhanced input action. And instead of a triggered like we did for our camera zoom, this one is going to be ongoing because we can hold it down. So let's do a print string just to test it out. And let's put in the print string throw test and compile and save. And we are ready to test it out with E. So E. And actually, as I hold it, you'll see throw test, but it only lasts about 3 seconds. And then I have to select it again. So now we have to use a new kind of function that we haven't done before, which is spawn actor from class, because what we want this to do is to spawn our projectile actor. So I can delete out our print string, and on ongoing, I'm going to spawn actor from class. And the class is, well, it's what we just created. So I'm going to select here BP_projectile. Select that. And we need to give our actor that we're spawning in the world an initial transform. So as soon as it's spawned, where is it spawning? How is it rotated? What's its scale? So from here, we can make a transform. So we can drag out a pin, make transform. And really, wherever we spawn it, it's going to be based on where our character's hand is at the apex of the throw, like when our character's arm is most outwardly extended. So first, we got to figure out where our character is, and then we have to extend that out in space, like relative to where our character's hand's going to be. And so the way we're going to do that is we're first going to get our character, really it's our actor, get actor transform. And the nice thing about getting the transform of the actor is this contains not only the location of our character, of our actor, but also the direction in which he's facing. And because it contains also the direction in which he's facing, we can project outward and upward a little bit for the hand. We can project out and up in that direction to get the final location where our projectile is going to spawn. And the way we do that, the way we project outward, is we can do something called a transform location. And the X vector, that's always the forward vector, like forward from our actor. And the reason I know that, if you go to viewport, so if we wanted to project out this mesh from the capsule, its parent, if I select the X location, if I say 50, you see how it moved further out. I'm going to put it right back to where it was. So we know that X is the forward vector. So if we go back to our event graph, and if we want to move that forward relative to our character, well, let's do about 50 centimeters, 50 units. And then the Y is going to be the left and right. I want to move it towards the right side, his right arm, because that's the arm that he's going to be throwing the projectile with. And we're going to move it 30 units. And then the Z, that's relative to his waist, like his center location, it's going to be a little bit higher, so about 20 units. So now let's connect this up to location, because that's going to give us our final location, 50 units forward from the character, 30 units to the right of our character, 20 units up from our character. And then compile and save. And this is going to do some ridiculous stuff, because you saw how many times it did the print string. Let's watch this spawn. Actually, you know what? Let's turn on our detailed stats, because I want to see how this affects our performance. So let's go to viewport, engine, detailed, and then play. And now if we hold E, it basically turns him into a human cannon, which is a lot of fun, but is not exactly what I intended. What we actually want to do is have some period of time where the character is throwing, and then during the throw, it's not actually doing anything, but then at the apex of that throw, that's when it spawns our projectile. So the way we're going to handle that, if I go back to our blueprint, we're going to create two variables. So the first variable is going to be called onThrowCooldown, one word. And that's going to be a Boolean simply to indicate, okay, is he currently throwing? Don't spawn another projectile if he's currently throwing. And then we're going to have a second variable called our actual throw cooldown. And this is going to be a float. And we'll compile and save that. And then the default value for that is going to be 0.5. And then what we're going to do, I'm going to take all of these, move these out a little bit. The first thing we're going to check on ongoing is we're going to first check to see, are we currently on throw cooldown? Because if we are, then we don't want to do anything, because then he's going to be in the middle of the throw cycle. But if he's not on throw cooldown, then we're going to get our variable and we're going to set it. And we'll connect this up just like this and then set our variable. And then connect this to spawn actor BP projectile. So these we'll tuck them underneath. And then after it spawns, well, it's going to be on throw cooldown indefinitely, right? So it's always going to be true here. So it's not going to spawn anything else after the first one. So how do we reset this value after a certain amount of time? So for that, we're going to use a delay node. And we've already done a delay previously, but now instead of a set amount of time, we can take our throw cooldown, drag it in, get, and then attach this there. So by default, it's going to be 0.5 seconds that it's delayed. And then we're going to take our set variable, I'll just control copy, paste it, connect this up, and we're going to uncheck that. So it's no longer going to be on cooldown after 5 seconds. And we are ready to test. So compile and save and play. And E, we can actually hold E, and then every 0.5 seconds, it shoots out. The next thing I want to do is I want to set our projectile when it hits something to actually be destroyed, because I don't want it endlessly bouncing around. It's going to have an effect when it hits, but we shouldn't destroy it on the very same tick that it's having an effect, because what that ends up doing is potentially interfering with the effect, not giving it the full tick to play itself out. So what we're going to do, if we go back to our projectile blueprint into our event graph, first thing we got to do is under sphere collision here, we got to make sure that we have simulation generates hit events checked. So this one checked. Make sure this is set to block all dynamic that we set. And then down here, we can say on component hit, we're going to do that event. And like we always do, we're going to test this first and foremost with a print string. We are going to test to say hit. You sunk my battleship. Haha. Compile and save. Play. So now, boom, 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 we see hit, hit, hit. Okay, so it's hitting multiple times. That makes sense. If it's rolling across the surface, it's going to be hitting every single tick. The other thing that's happening is when it spawns, if it's too close to our character, it's actually hitting our character's mesh. And that's going to be a problem, because if it's destroyed the moment it hits something, it's never going to actually project outward. So we need to tell the projectile to ignore collision on our character. We have to establish a relationship between the projectile and its owner, who created it. And that's our character. There's actually an owner relationship that we can establish. So if we go back to our BP platforming character, if you expand this, so if we expand it, we see this owner pin. And from there, what we can do is just get a reference to self. And basically what this is doing is saying, okay, this BP projectile that we're spawning, the owner is the platforming character. Compile and save this. If we go back to our projectile, so on event begin play, what we can do is there's actually a function, ignore actor when moving. And we got to make sure to choose that for our sphere collision, because that's the one that actually has collision. And the actor that we're going to ignore is, well, it's our owner. So we can get the owner, can delete out begin overlap, delete out event tick here, and connect this up just like this. And then make sure we check should ignore. Compile and save. And to be safe, we should do this on both actors. So we're basically telling the projectile, ignore our character. But what I'm also going to do here is I'm going to tell our character, ignore projectile. So we can get our capsule component on our character, and that's what has collision on our character. And we can say, ignore actor when moving. Connect this up there, and then return value for the spawn actor BP projectile, and then connect this way. And then say should ignore. Throw cooldown, move that over here. So these two, the ignore actor when moving, and over here this one, this is going to solve part of the problem, but only part of the problem, because it's going to ignore the actor for physics purposes, but it's still going to get on component hit here. So in order to ensure it's never going to get our player character, what we can do is go from other actor here, and we can cast to our BP platforming character. And this is going to ensure that, well, it's only going to hit if cast fails. So we can connect this up here. If it hits our player character, then it's not going to do anything. And we can double check that. We can make sure that that's the case, because we can connect up our other actor here, move that display name down here, and that way we're going to see what it actually hits. And compile and save. Try this out. So E, it's hitting the cube, and they do hit each other. You'll notice that too. They do actually hit each other. So occasionally you'll see that. Yep, projectile, projectile. And that's fine. So the last thing we're going to do is we're going to set up that destruction event on hit. And you heard me say we want to do it the next tick. So we are actually going to create a brand new event for that. So we're going to do a custom event. And the reason that we're doing an event and not a function is that we can do a delay in the event. And this one is going to be destroy self next tick. And we can call this event right up here as soon as the cast fails. But the nice thing about this is directly after this, we can say, well, delay. And there's specifically a delay until next tick. So we can give it that one tick to complete its actions when it hits. And then after it completes that, then destroy the actor. Now we're not actually doing any actions yet, but we'll get to that soon enough in the series. And the last thing here is print string. Well, we can get rid of that now. And instead on cast failed, we can call destroy self next tick. So it's going to call this and then it waits one tick and then, well, it should disappear. So compile and save. Let's give it a whirl. So, yep, disappeared, and boom, 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 boom. All right, one last thing. We got to give some velocity to our ball so that it actually moves forward when we throw it. So let's go back to the projectile. And actually, this is a key decision point. It's a good learning experience because we could add velocity right from the BP platforming character, or we could add velocity on the projectile itself. Because it's very frequently the case in Unreal Engine, or really any game development, that you have two different things that are interacting with one another. And the question is like, okay, should I put the logic of the interaction on the receiving end or on the giving end? In general, I'm going to advise you to put the logic on the receiving end. And the only reason I can say this is from time and time again, lessons learned, that putting it on the receiving actor, often you have multiple things that are impacting that receiving actor, and just having the logic in one place as opposed to the multiple things that are hitting the receiver, I found it much simpler to keep it on the receiver. So we're going to keep the logic for velocity on BP projectile. And if we're giving our BP projectile velocity, well, the velocity is an X, a Y, and a Z. And so we need to tell it which direction we're facing. And there's a few ways to do this, right? Because we could do it based on which way our character is facing. But I think probably the best way is which direction our camera is facing, because really that's where our player is aiming. So we're going to go to our BP platforming character. We'll get our camera rotation. We'll pass that in. But before that, let's add a variable on our BP projectile for direction. And this is going to be the direction in which our projectile is projected, moves. And we're going to make that a vector. And we've got to make that instance editable and exposed on spawn, because when it's actually spawned, we need to pass that in from our platforming character. So let's go back over to our platforming character now. So if we unselect BP projectile, if we go to none and then come back and select BP projectile, so don't change anything, but just come back to it, then you should see that direction variable because we exposed it on spawn. And we could get our follow camera, and we could get the world rotation of our follow camera, world rotation. And from the world rotation, we get our forward vector. And that's really the forward direction of our follow camera. And we could connect that up just like this. But what I found is when we're in first person point of view, it doesn't work right because our camera boom is changed in first person view. So the consistent way to always get the direction in which our player is facing is to get what's called the control rotation. Get control rotation. And the control rotation is based on the player controller, which is how the player is actually controlling our platforming character. And from here, we can get our forward vector, and then we can connect that up to our direction here. I'm gonna move this out just a little bit, give it some space, and then move these two up here. Now, if we go to our BP projectile, we got our direction, but we're not yet doing anything with it. But we got to do something on begin play. Like as soon as it spawns and begins playing, how are we taking that direction and then applying a physics force to it? So we can get our sphere collision here. And there are two different options. We could add a force, and it says add a force to a single rigid body. This is like a thruster, good for adding a burst over some non-zero time. Should be called every frame for the duration of the force. So we're not going to do that because it's just going to be on spawn when we throw the thing. The other option is we can add an impulse. If I hover over that, it says add an impulse to a single rigid body, good for a one-time instant burst. So we can take our direction here, drag in, get a reference to it, and we got to multiply it by some force, however much we want to project that out into space. So we can say multiply. So first I'm going to connect this up just like this, connect this up here, connect this up there, and then each one I experimented with this. I found 3,000 is pretty good. And make sure to check the velocity change button. And what this means is it means that whatever force we're putting on it, it's not affected by the mass of our sphere here. It's not affected by its weight. So we'll compile and save this, and let's test it out. It should apply a force immediately as soon as it spawns. So if I say E, boom, There we go. And because it still has gravity, then it sinks immediately when I spawn it. But because it sinks immediately, I actually found that giving it a little bit of vertical velocity, it has a better effect. So we're going to drag this out. We can do a plus sign here, and then we can connect this up just like this. And in the Z here, I'm just going to make this 60. Feel free to experiment with that number. It doesn't have to be 60 for you, but especially once we begin aiming our projectile, which is going to be in the next couple of episodes. But there's one last thing that I want to cover in relation to direction and adding an impulse. And man, I've said that like 3 times this episode, so I'm going to become a meme. The thing I want to mention is mostly related to gameplay that I got into further in the series, which is if our character is moving quickly, then this impulse of 3000, it's really not much of an impulse at all. Really what I want to do is I want to add 3000 onto whatever direction the player is already moving, because we want the impulse of the throw to be in addition to our character's current velocity. And so what that means is we need to pass our character's velocity in as a variable here. So we're going to create a new variable, and this will also be a vector, and we're going to make this our character velocity, and we're also going to make that instance editable and exposed on spawn, and we'll drag it in here, and we can add another pin to add that, and we will connect that up right here. So compile and save this. If we go back to our platforming character, we need to do the same thing where we say none and then go back to BP projectile, select that, and then we have our character velocity right there. And thankfully, it's very easy to get our character's actual velocity to pass into here. So to do that, we need to get a reference to our character movement component. And if we drag out from here and we search for velocity, if you scroll down all the way to the bottom, we have a get velocity node. From that, we can connect that right here. So that's the actual velocity, how our character is moving. So compile and save that, and we are ready to test. So if we're running an E, so even if we're running particularly fast, you don't see that right now, but in the future when our character starts getting abilities, then we'll be able to run a lot faster. But now that means that the projectile will always move in relation to, in reference to, however fast our character is moving. So that concludes our episode for today. Don't forget to cook, package, test. In our next episode, we take that projectile and I said a boom, chicka boom. We're integrating it with our animation blueprint. So I hope to see you there. And we got some cool stuff coming from members only in the near future. Talk to you soon.